Bertha, the machine that digs tunnels beneath cities. When a city wants to build a massive tunnel underground, ordinary excavators cannot be used. There are layers of soil and rock, with buildings and roads directly above them. That is why giant tunnel boring machines are used. One of the most famous is Bertha, one of the largest tunnel boring machines ever built. It was designed to excavate a massive tunnel beneath the city of Seattle in the United States, and its diameter was about 17 meters, wide enough to accommodate multiple traffic lanes inside the same tunnel. The machine operates like a giant rotating cutting head, breaking through the soil and rock in front of it, while tunnel walls are installed behind it at the same time. In this way, the tunnel advances meter by meter beneath the ground. But the project did not go as planned. After Bertha had advanced only a few hundred meters, it struck an old steel pipe buried underground. This damaged important parts of its excavation system. As a result, the machine came to a complete stop, and because it was buried beneath the city, it could not simply be pulled out. Engineering crews were forced to dig a massive access pit to reach its front section and carry out repairs. The process took many months, delayed the project by several years, and increased its cost by hundreds of millions of dollars. Despite that, Bertha eventually returned to work. It continued digging until it successfully completed the tunnel in 2017. But the surprise is that the machine did not emerge to the surface after finishing its mission. Because of its enormous size, most of its components were dismantled underground, leaving Bertha as one of the most famous examples of the complexity of modern infrastructure projects. Bagger 293. In some open-pit coal mines, the challenge is not extracting the coal itself. It is the millions of tons of soil and rock lying above it. That is why Bagger 293 was built, one of the largest land vehicles ever created by humans. It was built in Germany to work in open-pit coal mines, and it weighs around 14,000 tons. Making it heavier than the Eiffel Tower itself. Its length exceeds 220 meters, making it longer than 2 football fields placed end to end. Despite its enormous size, it requires only a small number of operators. At the front, there is a massive wheel carrying 18 giant buckets. As the wheel rotates, these buckets continuously dig through soil and rock and move them away. In just one day, the machine can remove around 240,000 cubic meters of material covering the coal seams. That is enough material to fill dozens of Olympic-sized swimming pools. But what is even more interesting is that its impact is not limited to mining alone. Years of continuous operation can completely reshape the surrounding landscape. That is why Bagger 293 is more than just a giant excavator. It is a machine designed to reshape the Earth itself. CAT 6090FS, the excavator that loads giant mining trucks. In massive mining operations, it is not enough to simply extract rock from the ground. Hundreds of tons of material must be loaded quickly to keep the mining process moving. That is why the CAT 6090FS was designed. One of the largest hydraulic excavators in the world. It weighs more than 1,000 tons, equivalent to the combined weight of hundreds of cars. At the front, it carries a giant bucket with a capacity ranging from 52 to 70 cubic meters of rock in a single scoop. As a result, it can load giant mining trucks in just a few passes. Unlike some older excavators that rely on cable systems, this machine uses powerful hydraulic systems that generate enormous force through fluid pressure. This gives it exceptional precision and rapid response. It can complete an entire digging cycle, including excavation, lifting, swinging, and dumping, in less than 30 seconds. These excavators operate in some of the harshest environments on Earth, from the deserts of Australia and Chile to the massive mines of North America. There, they face extreme heat, constant dust, and around-the-clock operation. Despite its enormous size, the operator sits inside a modern cab equipped with advanced electronic controls and monitoring systems, making the CAT 6090 FS an example of how modern engineering has enabled a small number of giant machines to perform tasks that once required large numbers of workers and equipment. Big Bud 747, the largest farm tractor ever built. When we think of giant machines, we often imagine mines or construction sites, but some of the largest machines in the world were designed for agriculture. One of the most famous is the Big Bud 747, the largest farm tractor ever built. It was manufactured in 1977 in the U.S. state of Montana to meet the needs of massive farms stretching across dozens of kilometers. It weighs around 45 tons and stands more than 4 meters tall. Its giant tires are equally impressive, with each one measuring more than 2.5 meters in height. But its size is not the only thing that makes it remarkable. Under the hood is an engine producing more than 1,100 horsepower, along with a fuel tank capable of holding around 3,800 liters of diesel. It was built to pull enormous agricultural equipment and operate for long hours without stopping. Thanks to its tremendous power, it can plow 24 rows at the same time, greatly reducing the amount of time needed to work large fields. After years of service, the tractor nearly became a museum piece or scrap metal. But it was purchased, restored, and returned to operation once again. What makes its story even more impressive is that it still holds the title of the world's largest farm tractor today, despite all the advances in agricultural technology over the past decades, making the Big Bud 747 a symbol of an era when the answer to any engineering challenge was simple: build a machine bigger and more powerful than anything that came before it. NASA Crawler Transporter, the machine that moves rockets to the launch pad. When we watch a rocket launch, we usually focus on the rocket itself. But before launch, that giant rocket must be transported from the assembly building to the launch pad. That is where NASA's Crawler Transporter comes in, one of the largest self-propelled vehicles ever built by humans. It was developed in the 1960s to transport the massive rockets of the Apollo program to their launch pads. The vehicle weighs about 2,700 tons when empty, and when carrying a rocket and its launch platform, the total weight becomes enormous. Despite that, its speed does not exceed a few kilometers per hour, because the goal is not speed, but maintaining the rocket's stability during transport. To achieve this, it relies on 4 massive track systems, along with a hydraulic leveling system that keeps the platform perfectly level even when traveling over uneven ground. The journey from the assembly building to the launch pad takes about 5 hours, even though the distance is only a few kilometers. Since the Apollo program, these transporters have carried nearly every major American rocket, including the rockets that took astronauts to the moon, the space shuttle fleet, and NASA's modern generations of launch vehicles. What is even more remarkable is that they are still in operation today after decades of service, making them one of the most important machines that have helped humanity reach space. Prelude FLNG, the largest floating structure ever built by humans. When a gas field is discovered far out at sea, the challenge is often its extreme distance from land. Building pipelines and processing facilities can cost billions of dollars. That is why a different idea emerged. Instead of transporting the gas to the processing plant, why not bring the processing plant to the gas field itself? This is how the Prelude FLNG project was born, the largest floating structure ever built by humans. It measures about 488 meters in length, making it longer than 4 football fields placed end-to-end. At full operating capacity, it weighs around 600,000 tons. It was designed to operate above offshore gas fields off the coast of Australia. There, it extracts natural gas directly from beneath the ocean floor, then processes it and cools it to approximately -162 degrees Celsius, turning it into liquefied natural gas that can be stored and transported more easily. The facility contains enormous storage tanks and fully integrated processing equipment, making it essentially a complete industrial plant floating at sea. But operating in this region is far from easy. The waters are exposed to powerful storms and tropical cyclones. To handle these conditions, Prelude is equipped with a system that allows it to rotate around a central mooring point so it can always face waves and winds from the most favorable direction. It also accommodates hundreds of workers, along with living quarters, restaurants, and operational and maintenance facilities. Instead of returning to shore frequently, the crew can remain and work on board for extended periods. Prelude is not just a giant vessel, it is an unprecedented engineering achievement that moved gas processing facilities from land to the middle of the ocean, making it one of the most ambitious engineering projects of the 21st century.